I'm trying to improve a model's precision for predicting customer churn. The model isn't performing as well as I'd like, specifically when it comes to correctly identifying customers who actually churn. I need to figure out which settings in my machine learning model will make it better at correctly predicting churn without making too many false positive predictions. Let's find out which hyperparameters I can adjust to increase the model's precision. I'll increase the minimum number of data points required to form a leaf node in a decision tree. This will make the model simpler, less likely to overfit, and therefore more precise. Think of it like this: the model will only make a decision if there's enough evidence to support it. I'll reduce the maximum number of leaf nodes allowed in each decision tree. Similar to increasing min_samples_leaf . This will simplify the model, reducing overfitting and improving precision. It's like pruning a tree. Removing extra branches helps it grow stronger and more focused. I'll increase the number of training iterations. This might improve the model's overall performance, potentially including precision, but it could also cause overfitting if not careful. It's a possibility, but I need to be cautious since it's not a guaranteed fix. I'm working with a HistGradientBoostingClassifier model in Sklearn. This is a type of machine learning model that's good for classification, which is what I'm doing here. I'm trying to find the optimal settings, hyperparameters, to improve its accuracy specifically in predicting positive cases, customer churn. I'll explain this one first because it's easier to grasp. Think of min_samples_leaf as the minimum number of data points needed to form a leaf node in your decision tree. Increasing this value forces the model to build simpler trees. Simpler trees are less prone to overfitting, meaning they're less likely to incorrectly classify a non-churn customer as a churn customer. This directly increases precision. This is very similar to the previous one. Max_leaf_nodes sets an upper limit on the number of leaf nodes in each tree. By decreasing this limit, I'm essentially doing the same thing, simplifying the model and making it less likely to overfit. Less overfitting leads to fewer false positives, and therefore, better precision. This one is a bit trickier. Max_iter controls the number of times the model iterates through the training data. Increasing it allows for more refinement, potentially leading to a better model. However, it doesn't directly address overfitting. It could improve precision, but it's not as reliable a method as the previous two because it depends on the other hyperparameters. The _learning_rate determines the step size the model takes during training. A higher learning rate can lead to faster convergence, but it also increases the risk of overshooting the optimal solution and overfitting. Overfitting causes a decrease in precision, so increasing the learning rate is unlikely to help improve it. I'm focusing on the hyperparameters of a HistGradientBoostingClassifier model, a type of machine learning model used for classification tasks, and how they specifically affect precision. I'm investigating the model's ability to correctly identify positive cases, like customers who will churn, without incorrectly labeling negative cases as positive. Precision is the number of true positives, correctly identified positive cases, divided by the sum of true positives and false positives, incorrectly identified positive cases. I want to find the hyperparameter tweaks that will improve this precision score. We'll look at how changes to these hyperparameters affect how complex our model becomes. A more complex model is more prone to overfitting to the training data. It learns the training data too well, leading to an inaccurate assessment of unseen data. This refers to the customizable settings within the HistGradientBoostingClassifier algorithm. I'm trying to find the optimal values of these settings so that the model accurately predicts customer churn. It's like adjusting the knobs and dials on a machine to improve its performance. The goal is to improve prediction accuracy, specifically the precision of predicting churn. The model isn't performing well enough in identifying positive cases, customer churn, which means it is producing many false positives or false negatives. We want to decrease the false positives, those instances where the model predicts a customer will churn, but they actually don't. I want to make the predictions more reliable by increasing precision, making sure the positive predictions are mostly correct. This is the core question. I'm looking at several hyperparameters and trying to determine how altering them will improve the precision of my customer churn prediction model. I'm essentially trying to fine-tune the model to make its positive predictions more trustworthy. This is a common task in machine learning, adjusting settings to enhance a model's performance. Increasing MINSAMPLESLEAF means I'm requiring more data points at each leaf node of a decision tree in the model. This is likely to improve precision because a less complex model will overfit less and lead to fewer false positives, increasing the reliability of the positive predictions. It's like making the model more cautious before making a positive prediction. Reducing the number of leaf nodes, MAXLEAFNODES, makes the decision trees in the model simpler. This will prevent overfitting, improving the model's ability to generalize to new data and reduce false positives, thus enhancing the precision of the model. The model becomes more conservative in its predictions. A higher LEARNINGRATE makes the model learn faster but can lead to overfitting. Overfitting means that the model performs really well on the data it's trained on but poorly on new data. This could harm the precision. Think of it as rushing to a solution without carefully considering all the data. Increasing the number of iterations, MAXITER, allows the model to train longer. While this might improve overall performance and might increase precision, it's not a guaranteed way to increase the precision alone. It is possible that it will overfit. It's like giving the model more time to learn. It might learn better, but it also might overthink the problem. I see, you're asking about increasing the min_samples_leaf parameter. Think of it like this. Each leaf in a decision tree represents a prediction. Increasing min_samples_leaf means you need more data points to form a leaf. This forces the model to create simpler trees, reducing the risk of overfitting and improving precision, as the model becomes less prone to making incorrect positive predictions. This is because a simpler model is less likely to latch onto noise in the data. Similarly, reducing max_leaf_nodes directly limits the complexity of each decision tree. It's like pruning a tree. Removing unnecessary branches. This prevents overfitting. The simpler trees, with fewer leaves, lead to fewer false positive predictions. Consequently, the model's precision will improve, as it's less likely to incorrectly identify negative cases as churn. Increasing max_iter means allowing the model to train for a larger number of iterations. That's good, right? Well, not always. It can improve overall performance, including precision, but it can also lead to overfitting if not carefully managed. Think of it like exercising. More reps can strengthen your muscles, but too many can lead to injury. You need to balance it with other factors. It's a less reliable way to specifically improve precision than min_samples_leaf or max_leaf_nodes . A higher learning_rate means the model makes bigger adjustments at each training step. This can lead to faster convergence, but it can also cause the model to overshoot the optimal solution, leading to overfitting and lower precision. Imagine trying to find a specific point on a map by taking huge steps. You might get there faster, but you're more likely to overshoot your target. I think of this hyperparameter as a control knob for model complexity. By increasing the minimum number of samples needed at each leaf node, you're forcing the model to make less granular decisions. This simplification reduces the model's tendency to overfit and thus produces fewer false positives, which boosts precision. It's like making your decision tree less bushy. More concise predictions improve precision. Similar to increasing min_samples_leaf decreasing the maximum number of leaf nodes directly limits model complexity. Fewer leaves mean a less intricate tree, which again reduces overfitting and the generation of false positives. The result? Higher precision. It's a direct way to make your model more focused and precise. Increasing max_iter lets the model train longer, potentially improving its overall performance and potentially improving its precision. However, this alone isn't a guaranteed path to higher precision. You could end up overfitting if other aspects aren't balanced correctly. Think of it as giving the model more time to learn, which could lead to better precision, but it's not a sure thing. A higher learning rate speeds up the learning process, but this can be a double-edged sword. It can cause the model to overshoot the optimal solution, increasing false positives and hurting precision. While there might be exceptions, it's not a reliable strategy for improving precision. Imagine teaching a dog a new trick. If you push it too hard, too fast, it won't learn well. The model's the same. I see that you're examining how hyperparameters affect model complexity. Remember, a simpler model is less prone to overfitting, which means it will make fewer mistakes. That directly translates to better precision, which is exactly what we're trying to improve here. The bias-variance trade-off? Well, a simpler model will have higher bias. It might miss some nuances in the data, but it will have lower variance. It won't be as sensitive to the specific data it is trained on. Finding the sweet spot is key to getting good precision. Let's talk about max_leaf_nodes . I think of leaf nodes as the final decisions a tree makes. Fewer leaf nodes mean a simpler decision tree. A simpler tree is less likely to overfit, because it won't try to memorize every tiny detail of the training data. This results in fewer false positives and better precision. Increasing min_samples_leaf forces each branch to have more data points before it makes a decision. Again, this simplifies the model. Think of it like this: you're less likely to make a hasty decision if you have a lot more data to consider, right? That leads to fewer mistakes and improved precision. Increasing max_iter maximum iterations lets the model learn for longer. That could improve things, but it's not guaranteed. It could lead to overfitting if the model is already too complex. It's like giving a student more time to study, helpful if they need it, but not if they're already studying efficiently. A higher learning_rate might seem like a good idea. The model will learn faster, but it can make the model learn too aggressively and overfit the data. That means a lot of false positives, which makes our precision worse. I see, you're asking about increasing the min_samples_leaf hyperparameter. That's a great question. A higher min_samples_leaf value means you need more data points at each leaf node of your decision tree before it's considered a valid split. This makes your model simpler, less prone to overfitting, and more likely to focus on general trends rather than noise. A simpler model is less likely to incorrectly label a customer as churning, resulting in higher precision. Think of it like this: a more conservative model is less likely to make false positive predictions. Decreasing max_leaf_nodes directly limits the complexity of your decision tree. Fewer leaf nodes mean a simpler model. Just like with min_samples_leaf this approach reduces overfitting. A simpler model has fewer opportunities to make mistakes and less prone to labeling non-churning customers as churners, which improves precision. It's all about creating a balanced model that accurately predicts churn without excessive errors. Increasing max_iter maximum iterations lets your model train for longer. It could improve accuracy and precision. However, it's not a guaranteed path to higher precision. If your model already has good hyperparameter settings, additional training might not significantly impact precision. It could even lead to overfitting, which harms precision. Therefore, I'd consider options C and D first. Increasing the learning_rate might seem like a good idea, but it can lead to overfitting. Overfitting means that your model learns the training data too well, and it might not generalize well to new data, leading to lower precision. Imagine learning to ride a bike by only practicing on the smoothest road. You might excel in that specific situation but would struggle on uneven terrain. It is not a reliable method to improve precision.